So we're going to apply these three I can statements. I can apply the change of base formula. I can condense a logarithmic function, and I can expand a logarithmic function. So these are all brand new things. You've never, ever seen this before in any of your math classes. So, and they're going to go pretty quick, actually. And we call these the properties of logarithms. So first of all, the change of base formula. It's an older thing. We don't use it as much anymore. It has some interesting ratio relationships. So if we have log base a of b, we're allowed to, it has this relationship where the log of b, the big number, okay, is divided by, and I could use any base here. So I could do log base 2 of b over log base 2 of a. I could also write it as log of b over log of a. And it's also equivalent to natural log of b over natural log of a. So we're allowed to use that relationship. So we're going to write it in a couple of different formats. So we're first of all doing this, I can apply the change of base formula. So we're supposed to rewrite the logarithm as a ratio of common logs and then as a ratio of natural logs. So these are ratios. Remember, fractions are ratios. So a is common logs. So I'm just going to go log, and I'm going to keep, I'm not worrying about the base. I take log of the big number in size, not in quantity. So log of 25 divided by the base, log of the base. So log of 4. To do the natural logs, I would just do natural log of 25 divided by natural log of 4. On example 2 here, again, I'm going to do log of the large number, 12, and then over the log of the base, 2. To do natural logs, I'm going to do natural log of 12 over natural log of 2. Okay. Peek over and check with the table partner to make sure you guys match. Okay. Okay. So on example 3, log of what? 6 divided by log of 5, and natural log of 6 divided by natural log of 5. Ridiculously easy, right? But if you were lived back hundreds of years ago, this would have been a super useful thing to be able to do that, because then you have to go from there and look up a decimal point. Nowadays, we can type it just the way it looks into our calculator. So it's kind of a silly thing. But again, there's places where it's useful to understand this relationship. Okay. All right. So this one's log of what? 57 over log of 10, and then natural log of 57 over natural log of 10. Okay. I think the homework only makes you do like common log or natural log, and it's going to tell you in the instructions. So just make sure you read the instructions carefully. Okay. All right. Any questions on this? All right. We're going to go backwards now. We're going to use the change of base to rewrite the logarithm. All right. So I got to go backwards and make it look like log base something of something. Okay. So remember, the base number is on the bottom. So log base what this time? This is going to be your base number on the bottom. So log base 3, and then this is the big number on the top here. So log base 3 of 8. I'm just reversing the property. Okay. Even though this is written as natural log, remember, I'm going to still use the common log for when I transfer it back. So I'm going to go log. What's the base going to be? 4 of 9. Okay. All right. 30 seconds. Try 7 and 8. Okay, check it with your table real quick. Make sure you all have the same thing. All right. I apparently have a typo in my notes, don't I? I just noticed it. Okay, so we'll have to make something up and put it there. All right, what's this first one? Log base what? 8 of 15. Okay. Let's just, I heard a 10. Let's assume a 10. It's not, I don't know what it was supposed to be. I apparently didn't type it well. Okay. All right, so log base 10 of what? 13. Yeah. Not necessarily. It just happened to be in these ones, and that's what I happen to do. It doesn't have to be. I could have it reversed, right? Natural log of 10 over natural log of 13, and then it would be log base 13 of 10. Does that make sense? So it doesn't have to be. It just what I picked happened to be. Okay. All right. That was a good question. Any other questions? All right. So that just took care. We're already down one I can statement. We just did that one. Change of base. We got white square down. Okay. So now we're going to do, I think expand comes next and then condense. Okay. So we're going to look at these properties here. So these are rules that are well known and have been proven. Okay. We're not going to prove them. We're just going to use the rules. Okay. So multiplication turns into addition. Okay, so this is the way we do that. When we're going to expand this logarithm, we would say log base a of u plus log base a of v. So do you see how the u and the v were being multiplied together? I can turn that into addition, and notice I add a second logarithm in. So these two statements are equivalent. I can go backwards too. If I'm adding two logs together with the same base, I can turn it into a single log and make it multiplication, which is really handy when you're trying to solve things to condense a logarithm down. Okay. All right. So if multiplication goes with addition, what do you think division goes with? Subtraction. Look at, aren't a division symbol and a subtraction symbol almost the same thing? They're both horizontal lines, aren't they? So those are the ones that go together. That's how I remember it. So the horizontal lines go together. All right. Logarithms are the study of exponents, okay? And they're ways to manipulate exponents. And that's what makes this next rule seems crazy, but it works, okay? Because we're manipulating exponents, okay? I am allowed to take whatever this exponent is, and I am allowed to put it in front. So I can move it the end to the front, log base a of u. Or if there's a coefficient in front, I'm allowed to move it up as an exponent on a logarithm, okay? So we're going to kind of start a little bit slow, okay? And then we're going to amp up into things that have radicals and fractional exponents, okay? Because you need to be able to do it all right? So, but I tried to add in there, I looked at the notes that I did the last couple of years. I'm like, oh, we need more practice with the easier stuff before we just head right to the hard stuff. So I tried to add some of the easier ones in here for you. Okay, so this is the brown squares. We're going to expand. Look at how simple those instructions are. It says expand. So that means I have one logarithm and I'm going to expand it into multiple logarithms. Okay, it might be 2, it could be 3, it could be however many we're multiplying together there. Okay. All right, I put a coefficient in front, so that turned it into 3 things actually. All right, so I am multiplying right here, right? What does multiplication turn into according to this? Addition. Okay, so because I have a 5 times an x cubed times a y, I've got to do 3 logs. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. All we're doing is applying the rule. Okay. To be fully expanded, I can't have any multiplications or divisions in there, and I can't have any exponents. So do I still have an exponent? Yeah, so I got to take this 3, and what was the rule on the exponents? Where are we supposed to land them? Put them in the front. Okay, so one more line on this. And I usually do that in 2 lines. Some of you are going to get to the point where you probably just use 1 line, because you're going to see the exponent and automatically put it in the front. But the first few, let's show the work. Okay, so you make sure you know where it's coming from. So that middle changed to 3 log base 4 of x. And all of them should have the same bases. You should go with whatever base was given to you. Okay? Okay. I want you guys, 10 is identical, except I changed my x's and y's to a's and b's, and I gave you more exponents. Okay? So everybody try example 10 right now on your own. Make sure we're trying it. Let's not be on our phone. We're going to have to quiz on it in 2 days, so make sure we're getting it. Okay, let's check it, okay? So we have multiplication. What does multiplication turn into? Addition. How many am I going to have? 3, right? Because I got 3 things being multiplied. If I only had 2, I would only have 2 things. I would only need 2, okay? All right, so log base 2 of what to begin with? 3, good. Plus log base 2 of what? A to the 5th, good. Plus log base 2 of b cubed. Are we done yet? We still have exponents. Where do the exponents go? In the front. So log base 2 of 3 plus 5 log base 2 of a plus 3 log base 2 of b. Okay? Remember, the point is that we're trying to get us to the point where we can solve equations with this, and this is a skill we need. Okay? All right, so that was addition and multiplication. Let's move on to another one. Okay? All right, so we're expanding again. Now I have division. What does division turn into? Subtraction. Okay, so I'm going to use a subtract in between it, and I'm going to do, there's going to be 2 this time. So log base 3 of x squared minus log base 3 of y. Am I done yet? No, I still have an exponent. Where's the exponent go? In the front. So 2 log base 3 of x minus log base 3 of y. All right, everybody try 12. You can do it. All right, I want you to check it with somebody at your table this time. So do a quick check with your table partner. Okay, let's check it together. What does division turn into? Subtraction. So I should have log base 5 of x cubed minus log base 5 of y squared. What happens with the exponents? Put them in front. So at 3 log base 5 of x minus 2 log base 5 of y. Okay, again, all we're doing is applying the rules they gave us, right? All right, I told you I would get you to some hard ones, right? Aren't you glad you didn't see those first? Okay. All right, whenever we have a radical, you're going to convert it to a fractional exponent, okay? Every time you see it and we're trying to manipulate algebra, because we do that all the time in calculus. Like before we can do any of the calculus stuff, we have to convert everything into fractional exponents, okay? Not that there's a fractional exponent in every problem, there's not. But whenever we have it, we got to convert it. So I'm going to rewrite it as log base 2 of a to the 1/3 power. There isn't a whole lot to expand other than we have an exponent. Where's the exponent going to go? In the front. So I have 1/3 log base 2 of a. And it could be any variable in there. It doesn't have to be just x's and y's. Okay. All right. We have a lot going on in 14. Okay. So I'm going to try to do it in as few steps as I can. So I'm going to do 2 things at once since we're in algebra 2. Okay. So first of all, what does division turn into? Subtraction. And this time it happens to be a natural log. The rules work the same for the natural logs. So I'm going to go natural log. Instead of writing that as a square root, I'm going to write it as a 1/2 power. That's the second thing I'm doing at the same time here. And then I'm going to do subtract natural log of 7. What do I still need to do to expand it all the way? Yep, move the exponent in front. So 1/2 natural log of 3x minus 5 minus natural log of 7. The only hard thing about this is just making sure you've got the three rules down, right? That's it. Okay? If you've got the 3 rules down, easy peasy lemon squeezy. Okay? All right, anybody, any other questions on that? Because I think the next one goes to condense, I think. All right, so now we're look at this. We're already through 2 I can statements. We've already done 2 of our learning targets for the day. We've expanded. We just have to condense. So guess what? We're going to go backwards on our properties. Instead of opening it up to multiple logarithms, we're going to jam it down to one single logarithm. And this one is probably the most helpful one as far as solving goes. Okay. So I'm going to work backwards. Let's go back and look at one of these. Okay. So if I look at the last line, to get from this line to this line, the opposite would be to take the exponent and move it up, right? And then to go from this line to this line, I turn the subtraction back into division. Okay, so all I'm doing is going backwards up the steps. All right, so first thing I see is when I see a coefficient, what am I going to make it? An exponent. Okay, so log base 2 of x plus log base 2 of y cubed. All right, what does addition turn into? Multiplication. So now I'm going to condense it down and put those the x and the y together, and it goes to one logarithm. Okay, so log base 2 of x times y cubed. That's our addition turning into multiplication. And that's all there is to it. Okay, they're pretty short problems, right? 2 lines. That's not common for us. Usually we've got like 5 to 10 lines on some of them, huh? All right, everybody try 16 on your own right now. So you're trying 16. All right, let's check it. What do I have to do with the coefficients in front? Make them exponents. Okay, so I've got log base 5 of a to the 4th plus log base 5 of b cubed. What does addition turn into? Multiplication. How many times am I going to write log? 1 time. So log base 5 of a to the 4th b cubed. Make sure you put it in parentheses. That's just a notation thing. Okay, so make sure it's inside parentheses. Any questions so far? All right, we're going to go simple again before we do. We make it a little bit harder. Okay, so first thing, when I see coefficients, what do they become? Exponents. So log base 4 of p squared minus log base 4 of q to the 4th. Apparently I got tired of x's and y's. All right, I have subtraction. What does subtraction turn into? Division. And how many times am I going to write log? Once. So log base 4 of p squared divided by q to the 4th. Technically, I should probably have parentheses around that. Sometimes I forget. Okay, everybody try 18 on your own. Okay, so you're trying 18 before we do the last 3. Okay, why don't you check it with somebody at your table? Check it with somebody at your table real quick. Okay, where does the number in front go? Exponent. We got to be careful on this one because it should be the exponent of both of those things. Okay, so it's going to be log base 3 of x minus log base 4 of 5y to the 4th. Okay. All right, and then what does subtraction turn into? If you didn't have this, make sure you get those parentheses on it, okay? All right, because that was a little bit tricky. That was my fault. All right, so we got to do division. How many times do I write log? 1. So log base 3 of x divided by 5y to the 4th. So that was started the tricky there. Okay, any questions on that?
How is there log 4 though? Base of 4.
Oh, that's my fault. What happened? That was terrible. I did a copy and paste job, so that should be a 3. Fix that to a 3. We couldn't put it together if it had that was my, I'm so sorry. All right. You're right. That was a really good catch. Thank you for catching that, because they should have the same bases in order to put them together. If not, we can't put them together. Okay. All right. Let's look at 19, 20, and 21 here. Okay. So we're getting into ones that are a little bit trickier and harder, maybe. Okay. All right. What do I have to do when there's a coefficient? Where does it go? Exponents. We're going to make those exponents. So we've got log base 10 of x to the 1/2 plus log base 10 of x plus 1 cubed. Okay. What does addition turn into? Multiplication. Okay, there's another thing that can happen there. So I know I've got to do multiplication. I know I've got log base 10. Is there another way to write x to the 1/2 power? I got to go back to a root. What's the same as x to the 1/2? No. Isn't that same as saying square root of x? Right? The denominator goes in the root, right? And the other exponent goes on the x. Okay? All right, so I could write it as square root of x times x plus 1 cubed. That was ugly. Told you I saved the ugly ones for the end. Last year, that was the first example on that. So I added some other ones in there to make sure we got it down first. All right, we'll be good on that one. We understand why I switched to square root. It might not, and depending upon the answer, it might just leave it as x to the 1/2. So, but it could convert it. So I want to make sure you see the conversion. All right, so when we have a number in front, where does it go? Exponent. So we're going to go now, and it doesn't matter that we're in natural logs now. Natural log of x plus 2 squared minus natural log of x. All right, what does subtraction turn into? Division. How many logs am I going to write? 1. Okay. So I've got x plus 2 squared over x. Sometimes you'll see it when it's division just written like that without the parentheses. You don't really need them on division. On multiplication, you definitely do. Okay. The last one is really weird. Okay. And there's lots of different ways that you can do it. I am going to follow, please excuse my dear Aunt Sally. Okay? So please excuse my dear Aunt Sally says we do stuff inside the parentheses first, right? So that means I'm going to do this condensing first and then deal with that exponent that's on the outside. Okay? I could distribute and I would get the same thing, but I think I'd have more simplifying to do at the end. So I'm going to keep the 1/3 out there. All right, so I don't have anything to move up as exponents right now, right? So what does addition turn into? Multiplication. So I've got log base 2 of x times x minus 4. Okay. Now, this kind of depends. If it was open-ended, I would do one thing, and if it was multiple choice, I'd probably do another. But we tend to simplify as much as we can. What's instinct telling you to do with this x? Distribute. Okay. So I'm going to go 1/3 log base 2. What's x times x? Good. And x times -4. Good. I'm not fully condensed yet because I have a coefficient. What do I need to do with that coefficient? Make it an exponent, right? So I have log base 2 of x squared minus 4x to the 1/3 power. Now, if we have a 1/3 or a 1/2, we're probably not going to see a fractional exponent. It would probably go back to a root. So we'd probably bring it back here. What number is going to go in the root symbol? 3. Good. X squared minus 4x. You don't really need parentheses. It's just to the first power, so that would be good. Okay? You guys, both of these last two are really good, acceptable answers. If it was open-ended and you got to this, I would be thrilled. Okay. And I would give you full credit for it. All right. But you need to be really well aware of the other one. Okay. Because you never know. We have SBAC coming and ICAs coming and next year calculus coming. So we need to make sure we're getting to we understand both. Okay. All right. Guess what? We just checked off 3 I can statements today, didn't we? That was the last question, wasn't it? Yeah. So we got through all 3 of those today. And we've got time to spare, like lots of time to spare. Okay. I put the baskets out because there is a homework assignment that's Delta Math. The one thing in the homework assignment, because I made up a couple problems and put them in Delta Math because they didn't have any for these first few. You have to hold, and it tells you in the instructions, you have to hold down your shift and the underscore to get the lower exponent because it didn't have like the nice little structure like Otis does. Okay. So when you get to those, it tells you that. Okay. So that you can use it. All right. I would get to work on the assignment. Just practice a little bit before you leave today. Okay. Get it done. Because remember, when is the quiz going to be? Thursday. Okay. We'll do review tomorrow. Okay. Yeah. Yeah.